Hello everyone, welcome to Try Rights, the new era of learning. My name is Sheikh Abdul Rafiq and I am your data science trainer. Let's move into the topic. Today's our topic is data science regression table. So in regression table we usually use output from linear regression can be summarized in a regression table. So in simple terms we can say that a regression table is a key output in a data science when you're performing regression analysis. Okay, it summarizes the result of the regression model, including a few steps like this: information about the model, coefficient of the linear regression function, regression statistics, and statistics of the coefficient from the linear regression functions. Right. This is some of out of the regression table. So other information that we will not cover in this module. Now, this is the output of the regression table, which includes all the information about the healthcare data, which we considered before in previous sections. So in this table shows the how the output is measured. So what R squared and adjacent R squared and p value and static error and coefficient value and dependent variable method and time, all these included in this table. So to create a table like this, we want to implement some steps like kind of codes. So in that we use the stats model for formula and statistical in using Python. So we let's create a code. Let's create a table by using code. The given instruction is given to how to implement the code to create the table structure like this. So let's open to the VS Code and now create a regression table. Okay. From first we all know we want to import the pandas to read the file, right? What pandas has, pandas has PD, right? After this, we want to import a model called stats model. So stat model, we want to import this model from a formula based is a formula dot API. It is a non function in stats model. We want to call that it consider as SMF. I consider as SMF. Okay, now the use PD dot read CSV from the and here I want to consider, so this is my data healthcare data here CSV, right? Hmm, so I consider the healthcare data here, healthcare data dot CSV here, and keep into a variable like GLT health data. Okay, now further output. Now we want to create a model. See here, we want to create a model. It's also given explanation. Import a library starts. We already imported it. Use a full health data. We consider a health data set. Now see, create a model based on the original least square, which SMP is called to create a model. Notice that the explanatory variables must be written first in the parentheses use the full cell data set. So it just means we want to create a model which considering the SMF has a stats model formula and OLS. OLS nothing but ordinary least square. So we consider this both. So now take a variable has model. I is creating a model and take SMF and dot OLS. OLS I said OLS nothing but ordinary least square. It is a it's a, just like it is a method like R squared method like. So here I was considering two of my data for in reverse order I want to take. So I take calories data and first I'm considering calories data. Here one logic is there. Here you don't need to divide the code. You just simplify the code as like this. So I'm follow the data both data into a one angle. So I want to assemble that into a one function. So for that, I asked to create, wait, my data is separate. So right like this. Uh, so this way I want to create a line-based order code. So in that I has considered data equal to. I want to consider my health data again. So for that, I want to create a variable, and for that, I want to create a model dot fit. So it must be fit into the according to the data. So create a variable name has result, keep in the value, store in the variable, and print it the variable. Here, if we have a function called summary, as where if we have a function called summary, is nothing but it calls the function to have output. So it calls the function. Okay, now save the code. Okay, now run the code. It will create a table form data, table form data. Wait, creating is running. See, now data is run clearly, right? Here I get the data. See here I get the data. So I want for more clarity information, I take the screenshot. So for this data, I will uh, detail you everything. Now regarding this data, I will give you more clear information about this table. So now see, this is my table, right? I'm taking into the so I want to give information more. So in this table, data science, it is a information part in the regression table, right? So wait a second. Wait a while moment, guys. Please take the video, right? I didn't want to show get into the video image. Where is my paint option here? It doesn't getting to my paint. Wait a second. Okay, now right. It's okay. Designer, I take into a designer. All right, it's okay. It is better. So here I take the right. Okay, now this no, I didn't want this much thickness. So here the variable, right? So see here. I considering this is my data table, right? This is the data table which I want to consider here. So this is my data table. So in this, df variable is nothing but it is a short form of the dependent variable, right? For the calories burnage is the dependent variable. The dependent variable is here assumed to be explained by the average pulse, right? And the model is OLS. Sorry, okay, right. OLS. The model is OLS, right? It is a short form for I said no ordinary least square, right? This is a type of model that uses the least square method. Okay, here we can see the date has today's date and time which we implement. So this kind of table will be created whenever you implement the square list method in the or you use a regression table. So let's see the coefficient of part in the regression table. So coefficient part is nothing but this is the coefficient part of the table. So the considering this part has coefficient part. I consider this part has coefficient. This is the coefficient part of the table, right? This is the coefficient part of the table. So in this, the coefficient part is nothing but The intercept, we has an intercept, an average pulse, and the coefficient value, right? Coefficient is a short form of CO is short form of coefficient, right? It is the output of the linear regression functions, right? The linear regression function can be written as mathematically. Okay. Now see, those number means if the average pulse increased by one, right? Let us assume if the average pulse is increased by one, calories burned increased by 0.3, something, right? If this will increase, or it also increases by range in between of just little bit points, right? Around one, two, or three rounded. If average pulse is constantly zero, calories burned is equal to the 80, or little between of 80.80, 0.00, or 80.10, like this. Similarly, in between the range. Okay. Now remember that the intercept is used to adjust the model's precaution of the predicting. So we use to this is for predicting, right? Okay, we use it for predicting, and this is and another part of the table is and take the now this part is nothing but we call this part as static standard deviation or static coefficient, right? We call as static coefficient table. We called as static coefficient table. Okay, here the static error, t value, and p value is called. So in this, we have to consider test is we want to test the coefficient from the linear regression function has a significant impact on the dependent variable on calories burned. Okay, so that means that we want to prove that there existed a relationship between the average pulse and calories burned, average pulse and calories burned. Okay, using the statistical test. So therefore, we can consider this table has p-value has and now STD error. So STD error is nothing but standard for standard error. Stands for standard error. Okay, where the error gets stands for standard error. Okay, and T is nothing but also the T value of the coefficient, and P greater than T value is nothing but is called P value. P is nothing but called as P value, and the range of 0.2025 and 0.975 nothing but it represents the uh, confidence interval of the coefficients. Okay, this is the output which we consider into the regression table, right? I hope you understand, guys.